Today, we'll study about number representation that represented by binary code. Okay, the keyword is code. Code, in general, it may be number or some kind of symbol to represent something. For example, your student ID may be 6305 and something. For this number, this number may be represent to Mr. A, for example, and 6305 YYYY may be represent to Mr. B. Okay, so for one set of number or code, normally it represent only one thing. That means two things or two person, okay, should not be represented by the same code. If not, some problem will be occur, right? For example, if I assign for example, if I give grade grade A for Mr. A and grade B for Mr. B. Okay, in for example in transcript or in database, if I represent A by this code and give grade A, and the next one Mr. B. If I use the same code, what happened? This one also, you get B. Okay, some conflict almost is quite confused, right? That this grade is for Mr. A or Mr. B, right? Because it represents two or more things. So basically, for one code, for one code in the same system should represent only one thing. That means if you use binary code, for example, if you use 4-bit of binary code, that means it can represent up to 1, 2, 3, 4 4-bit, right? Then it can represent up to 16 things, right? Maybe number, maybe some something, okay, some condition. So today we will use binary code to represent number, okay, with some specific fixed size. For example, if I use 4-bit, that means it can represent the different value up to 16. The first one is called unsigned number representation. For this system, we represent only 0 and positive number. For this system, use 0, 0, 0, 4, 0, 0, 0, 1, 4, 1, 0, 0, 1, 0, 4, 2, 0, 0, 1, 1, 4, 3, and so on until 1, 1, 1, 4, 15. Okay, that means it can represent for n bit, it can represent 0 to the power 2 to the power of n minus 1. Okay. Now let's try to do something like addition. For this number representation, at first, the relation between binary code and its decimal value. Actually, you can do conversion between decimal value and binary code directly, okay, as you already studied for the previous lecture. Okay, now let's do something. If I have some binary code in this system, unsigned number 0011 and for example 101, okay, and do addition between these two numbers. What happened? 1 and 1 is 0, right? Then carry out is 1, this 1 add 1, and this carry in, then it become 0 and 1 carry out. This carry out become carry in at this digit, and then 0 plus 1 plus this carry in, then it becomes 0, and then carry out is 1, and then become carry in 1 and here 0 plus 0 is and plus carry in 1, then it become 1 0 0. Okay, for this number in this unsigned number representation, this binary code is represent 3, right? And this one is 5, and this one is 8. Okay, you can see that you can do addition directly with the binary code. Okay, you can obtain the correct result from this one. Anyway, what happened if I do the addition between this number? For example, this one 1010 and 0111. Okay, if I do the addition, this 1 at here, 0 at here, 0 at here, 0 at here, 1 at here. Anyway, for now, let's use only 4-bit, right? This case only 4-bit. So you keep you use only 4-bit. Okay, for the last bit, you don't use. So what happened? 001. At first, this one is represent 10, right? This one is 7. This one represent 1. What happened? 10 plus 7. It should be 17, right? But your result is 1. So what happened? Okay, it's wrong, right? It's incorrect result. That because if you use only 4-bit representation, it can represent the number up to 15, right? But your result now is over, right? It's greater than 15. So the problem occurs. That means now is 101, right? Or 10, right? And then you add 7. 1, 2, 3, 4, 5, 6, 7. Okay? Then and the result is 001 or 1 in decimal. So it greater than the maximum number that can represent by 4-bit. It is called overflow. And if you do some subtraction, maybe in this direction, if it's lower than the minimum value, it's called underflow. Anyway, in general, often we say only overflow for two direction when it's, the number or the result is greater than the maximum value, and the result is lower than the minimum value. Okay, let's use overflow. Okay, now for this unsigned number, it represents only 0 and positive number. It is don't use for negative value. If you want to use negative value, maybe this one. Let's consider this one. For this number system, the binary code, okay, can represent both positive and negative number. So for positive number, for example, 3. Normally you write 3 or with plus sign, right? And someone write nothing at here, right? And minus 3. Okay. How to write 3 and minus 3 with binary code? Normally 3 is 1 1, right? In binary. Okay. If you want to write to minus 3, what should you do? It is 3 and then you add sign plus AC or minus AC. Is this okay? No. Don't forget that in your digital system, the signal or voltage in the circuit can have only 2 levels, right? High and low. That means if you use, for example, your value maybe have 0, right, in the system, or 1, right? But if you use plus sign or minus sign, that means there are more, right? More 2 things that you should represent by 0 1, which is cannot. So what should you do? So we cannot use minus and plus here, right? That means the thing that can use, okay, it can use only 0 or 1, right? So I must use something, okay, to represent plus and minus. Okay, so what should I do? Okay, I should select 0 to represent plus, or 0 to represent minus, or use 1 to represent plus, or use 1 to represent minus, right? Okay, actually anything is okay, right? Just different, not the same, is okay. In this case, based on this one, normally for the positive value, we may write nothing, right? Okay, for the positive sign. So in this case, we use 0 for positive sign and minus, okay, minus. I use 1, okay, to represent minus. Okay, then the MSB in this sign magnitude representation, okay, this MSB, okay, the most left digit, it's used for sign bit. Okay. If MSB is 0, that means this number is positive. If start with 1, it's minus value, and the left digits is represent magnitude. For example, 0 is plus, 0, 1, 1 is magnitude of 3, and from minus 3, 1 minus and magnitude 3. Okay, it's convenient, right? Just magnitude and sign. You can write down any number. Anyway, when you use this number, for example, to do addition. For example, if you do this one, 0, 0, 1, 1, add 0, 1, 0, 0. The result is 1, 1, 1, 0. This one represents what? 3, right? This binary code represents 4, and this represents 7. 47 is okay, right? 3 plus 4 is 7. Okay, no problem. When you do addition between positive number. How about this one? if you do this one 0 sorry 1 1 1 1 0 1 1 and 1 0 0 1, how about this 1 and 1 0 0 1, and how about this 1 and 1, right, is 0, right? Your result is what happened? Minus minus and change to what? Minus 3 plus minus 1, and your result is plus 4. It's incorrect, right? Incorrect. That's the problem. You cannot do addition, okay? For this, someone may say, oh, then can we keep side bit at here, okay? At here. Of course you can, but you must check, right, that this number is positive or negative, and you use different procedure. And how about this one? For example, 0 0 0 1 1 plus 1 0 0 1. Your result is what? 0 0 1 1, right? This number is plus 3, right? This is minus 1, and this is minus 4. Oh, it's not okay, right? It's not okay. So you cannot do addition, okay, between positive number and negative number directly, easily in this number system. This is just disadvantage for this sign magnitude representation. One more disadvantage point is zero value. There are two binary codes that represent this one. That means if you want to check that your result is 0 or not, you must check two codes, which take time. It's not so good. Okay, by this disadvantage, so the next number representation system. Okay, let's introduce to this one. For this one, okay, this is the binary code, and this one is the decimal value. Okay, at first let's try to do something. Let's try to do addition for this number system. For example, this one. Okay, the result is what? Is 0 0 1 1, right? In this number system, 0 0 1 1 represent plus 3, and this one is what? 1 0 0 1 1 0 0 1 is minus 7, right? And this one is minus 4. Oh, this number system is so good, right? Because you can do addition, okay, directly in binary code, right? And your result also correct, okay, also correct. It's very good. So then let's see, study in the detail. At first, let's consider the positive side. For positive value, again, it's beginning with 0. MSB is 0, and you can do conversion between decimal and binary directly. That means if you want to know to know the value of this binary code, you just convert from radix 2 to radix 10, right? Process. Or if you want to write binary code for this decimal value, you just convert radix 10 to radix 2. Okay, as you already studied for the last lecture. Anyway, how about this sign, negative sign? you cannot convert by the ready number conversion directly, right? So what should you do? Okay, let's consider this one. For this number plus 3, when you do the addition plus 3 to minus 3, what happened? Your result is 0, right? So based on this one, you can do something like this. If I add 0, 0, 1, 1 with 1, 1, 0, 1, what happened? 1 add 1 is 2, right? Anyway, you can write with 0, okay? And carry out this one. And this carry out become carry in for the next digit. 1 add 0 add 1 is 2. But you write 0 and then carry out is 1, right? 0 add 1 is 1, then is 2, right? But you write 0 and 1 carry out. And then 0 plus 1, 1 is 0, something like this, right? Okay, your result is 0, 0, 0, okay? And ignore this bit, right? Because now your system just only 4 bit, fixed 4 bit, okay? Use only 4 bit. For the next digit or 5th bit, you don't use it. So that means if you want to know the value of 1101, you know that it's beginning with 1, right? You know that it's negative value, but you cannot convert to decimal directly. So let you find out the pair that can give the result of summing to 0, 0, 0. So you just consider what kind of number that add 1 and give 0. Yes, it's 1, right? After 1 add 1 is 0 and 1 carry out, right? Then you just consider 0 plus something plus 1 carry out and give 0. Yeah, it's 0 at here, right? And then the next digit 1 plus something plus 1 carry in, right? So it should be 0 at here again and 0 at here. Okay, and let's check. 1 plus 1 is 0, right? 0 plus 1 carry in, then it becomes 0. 1 plus 1 plus 1 carry in is 0. 1 plus 1 and 1 carry in is 0. That means it's pair, right? These two numbers have got the same magnitude. If you know that this positive, right? This positive is magnitude 1. This one is also magnitude 1 but different sign. That means this number represent minus 1. Okay, you just find out the pair of them. So because if you observe that when you do the addition for each digit, your result is 2, right? Your result is 2. So this number system is called 2 complement representation, because this one and this one is complement together. When you add it, when you do the addition, for 8-digit addition, give the result of 2. Okay, these 2 complement number system often used in, for example, in computer system for represent the signed number. Okay, now anyway, let you do something. Oh, how about this one? I missed this one. For this one, 100, if you consider from this direction, is to come from 0 plus 1 plus 2 plus 3 until plus 7, right? But in this direction, okay, it's minus 1, 2, 3, 4, 5, 6, minus 7. How about this? It should be minus or plus 8. Yes, it should be minus 8, right? Right? Because it's beginning with 1. Okay? So that means this number system It can represent from 0 to plus 7 and minus 2 minus 8. Okay, so right in general for 4 bit, right? For n bit, that means for n bit it can represent what? For n bit, that means if you use for the assigned bit, right? That means you the left n minus 1, okay, bit can represent for positive value up to the power of n minus 1 minus 1, right? Like this case, right? And for the negative value is minus 2 to the power of n minus 1. This is the length that can represent by n bit binary code. Okay. And okay, let's consider the next. Okay, if I do addition plus between this one and this one, this is positive value, this is positive value, and your result is this one. And opposite carry out. 1 plus 1 is 0, carry out is 1. 1 plus 1 is 1, carry out is 1. 0 plus carry out 1 is 1, right? And no carry out. And 0 plus carry, no carry out. That means carry in at digit is 0, then give 0. Okay, no carry out. Okay, this one is no problem, right? You will obtain the correct answer. For this example also, it is correct answer. This one also correct. Get result. But let's consider this one. 0, 1 by 1 plus 0, 1, 0, and the result is this one. Is it okay? This and this 0, 1, 1 represent 7, right? And this one is what? 0, 1, 0, 1 it represent it's 3, right? How about this? This one is what? Minus 4. Oh, it's not okay. Why? Why? That because what? 7, right? Plus 3, right? Plus 3, 7 plus 3. 1, 2, oh, sorry, it's not 3, sorry, it's 5, sorry. 5 here, right? 1, 1, 2, 3, 4, 5. Okay, add here. Okay. Okay, because this number system for 4-bit, right? In 2 complement number system, it can represent up to plus 7. But now your result is over, right? Or than 7. So it's overflow. Okay, overflow occur. This example also. Okay, this is minus 3, right? And then you plus what? This one is minus 6. Then 1, 2, 3, 4, 5, 6. Okay, then it's become this result. It's overflow. Okay, it's less than the minimum value that can represent by 4-bit in this number system. Okay, so if your result, okay, if you do the addition between positive number and positive number, and your result is negative, it's not correct, right? That means overflow occur. If you do addition between minus and minus number, and your result is beginning with 0 or positive, that means overflow occur. Okay, back to this one. If you do addition between positive and negative, and the result is positive, okay, it's correct. Okay, minus is okay, right? No overflow. Okay, how about this? Positive number and negative number. When you do the addition. Your result always not overflow. Okay, why? Overflow cannot occur when you do addition between positive and negative number. Okay, because for positive number, right here, maybe this one, right? And when you do, okay, for example, this one is 7, right? Then I start from this one, and 4 minus value, 4 minus, okay, it's opposite, right? Opposite direction. That means your result, when you do the addition, the magnitude of result always less than the maximum number between two numbers that you do the addition. Okay? You also cannot, right? The magnitude always decrease, okay? When you do addition between positive and negative number. Then the overflow cannot occur when you do addition between different signed number. Okay, this is the point. Anyway, actually you can take the carry out this 2-bit. If this 2-bit MSB and the next digit, if you get the same value, namely 00 or 11, overflow cannot occur. Okay, overflow not occur. But if your result is 0, 1 or 1, 0 is different, that means overflow occur. Okay. This is the second method that you can check overflow occur or not. Why? Why when you do, for example, actually you can, if you know that this character is 0, 1, that means the overflow occur from positive and positive and give negative result. And for this one, if carry out beginning with 1, 0, that means it from negative add negative and give positive result. Why? Let's consider, for example, some value. You don't know something, right? And this one is also some value. Okay, and some result of addition. If this one begin this one 0, okay, and something. Okay, let's consider why if you know that carry out beginning with 1, 0, it come from negative value plus negative value and become positive value. Okay, let's consider now carry out 0, right? This carry out, okay, will be carried in to the next digit. That means carry out is 0 right here, right? And when you do the addition, you must add the digit with the digit and this carry in, right? And your result is something and carry out this one. This digit, the possible value is maybe 0 and 0 or 0 and 1 or 1 as 0 or 1 and 1, right? But only one case that when you add this number, add this number, and add this number, and give one carry out. There's only one case, right? Namely this one, right? 1 and 1 as 0. Okay, then you give one carry out. Okay, so it should be 1, 1 at here, and 1 at 1 at 0. Then it gives 0 at here. So in this case, then 8, 1, 1, negative, negative, and give positive. So it's overflow. Similarly, if your result gives the carry out beginning with 0, 1, something, right? And you carry out beginning with 0, 1. Again, this carry out will be carry in at the next digit, and you do the addition this digit, okay, add together and give no carry out. That means this bit and this bit must be 0 both, right? And your result is 1, okay, and no carry out. So that means it's positive and add positive and give negative result. So it's overflow. Okay. Now. Okay, now you know, okay, the limitation and the advantage of this number system. Well, now if I want to write down the binary code that represent a decimal value in this system, what should I do? Okay, it's very easy. At first, you must be know that the value that you want to write, okay, is positive or negative. If it's positive, okay, the MSB will be 0, okay, beginning with 0. Side bit is 0. But for negative, okay, side bit is 1. Okay, same as magnitude, sign magnitude. Okay, for positive value it's easy because you can convert the value between this decimal value and binary value. But how about negative one? Okay, and you know positive and negative, when you do the addition, the result will be 0, right? Okay, so I do some practice. For example, if I want to write down 6 bit, okay, 6 bit in two complement number system. Okay, let I start with 5. For 5, for positive number, you can write number like convert decimal to binary. Namely, it should be 0, 0, 1, 0, 1, or 6 bit. Okay, 0, 0, 1, 0, 1. Okay. For 5, if I want to write down -5, what should I do? Of course, I should write binary code for 5 first, right? For 5 first, and then let you find out some number that add to this one and give the result of 0, 0, 0, right? Then is what? It should be 1 at here, right? 0 at here. No. It should be 1. 1 at 1 is 0 and 1 carry out, right? 0 at something at 1, that means it should be 1 at here, right? And 1 carry out. 1 at something at 1 carry out and 0 at here, so it should be 0, right? 1 at 0 at 1, then it becomes 0 and 1 carry out, okay? And 1 carry in is 1 at here, 0 at something at 1 carry in, give 0, that means it should be 1 at here, right? And this one should be 1 here and 1 here, right? So if you can find this pair, namely you find the two complement, it said this number is two complement of this number, or vice versa, namely this number is two complement of this number also. Okay, you can find this pair. That means this one is represent plus positive 5, right? That means this one represent -5. So now you can write binary code for -5. Okay. What about this one? Okay, let you find two complement of 0, 0, 1, 0, 1, 1, 0. Can you find it? Okay. Okay. If you want to know the value of this one, oh, it's negative, right? is negative. That means you must find out the pair or two complements of this number. Namely, find something that can give the result of addition between this number and this number, okay, as 0. So it should be what? 0 at here, 0 at here, right? 1 and something 0 there is 1 at here, right? And after this digit addition, it always have 1 carry out, right? That means the next digit will have 1 carry in. So when you do the addition, this number, okay, should be 1. This one should be 0, 0, 1, 0. Namely, you can observe if you start to consider from LSB bit, LSB, if the bit is 0, okay, its complement is 0. This bit is 0, its complement is 0. The digit 1, okay, the first digit that is 1, the complement of this digit still be 1. Okay, and after that, it will opposite value, namely, if this one is 0, this will be 1 at here, is 1 at here, is 0 at here. Because from this one, the carry out or carry in always 1. Okay, always 1. So if you know now if you can calculate, right, the positive value. Namely, if you know the weight for this one is 1, 2, 4, 8, 16, right? 32 and 64. That means your result is what? Is 76, right? 76. Okay, that means this number represent minus 26. That's all. Similarly, if you want to write down binary code for some number, okay, you just consider it's positive or not. If it's positive, you can, for example, for 4 bit, okay, for 4 bit, you can write down or convert directly from decimal to each binary, something like this. But if you want to write down negative number, you cannot. For the beginner, okay, you cannot write it directly. So you could find the pair, okay, binary code for it, okay, each pair. Namely, it's positive value. So it's 0, 1, 1, 0, right? For this sample. After that, you just find, okay, just find the pair, right? That can give 0, 0, 0, 0, right? So it's 0, 1 at here and 0, 1. Okay, okay, this is the binary code for -6. Anyway, if you want, for example, if you do some addition and overflow occur, can you solve the problem when overflow occur? Yes, one thing is that you extend, right, or increase number of bits. If you want to change or extend from 4 bit to 8 bit, for example, if you want to extend, okay, this 4 bit to 8 bit by keeping its value, namely, if I want to know this value, right, and if I its pair, right, then it's 0, 1, 1, 0, right, 8 plus 6, right, then you just find, right, okay, this positive number first, right, and then you extend to 8 bit. After that, you just find the number, right, that can give 0, 0, 0 as the result of the summing between this one and this one. Okay, and its 2 complement is what? 1 0, and it should be what? 1 1 1 1 at here, right? That means for positive number, you can extend by add what? Add 0, right? 0 0 0, right? But for negative number, you can extend this bit sign by adding 1 1 1 1. Okay. Okay. And okay. And let's consider this one. This number x, okay, plus its 2 complement plus 2 complement of x, and the result will be 0 0 for n bit, right? If you add more 1 bit, it should have 1 at here, right? That come from carry out, okay, from this digit addition, or its value is 2 to the power of n. Anyway, if I want to find 2 complement of x, then I use the number minus x, right? Or this number, actually you can write it as 1 1 1 1, n bit of 1 1 1 1 plus 1, and then I move minus x to here and plus 1, okay, to here. So you give some number of this one. This number when add x, namely 1 1 1 1 minus x, this number, this value, plus x, you give 1 1 1 1, right? So this number is called 1 complement of x. For example, 0 1 0 1 1. Its 1 complement is what? It's some number that when you add together, give the result of 1 1 1. What's the number? 0 at here, right? 0 at here, 1 at here, 0 at here, and 1 at here. So this number is 1 complement of this number. No, you just invert, right? Each bit 1 to 0, 0 to 1. Then you will obtain the 1 complement. So when you use this 1 complement plus 1, add 1, you will get 2 complement of x. So another method that you can calculate 2 complement to find out 1 complement of x and then plus 1. For 1 complement of x is easy, right? You just invert each bit, then you will get 1 complement. And how about if you want to do the addition or subtraction? For addition, actually you can do it easily the same way of unsigned number. How about subtraction? For subtraction, you can do something like this. For example, x minus y, you can consider it as x plus minus y. For minus y is, you can use 2 complement of y, okay, 4 minus y. And for 2 complement, you may calculate by find out 1 complement of y and then plus 1. Okay, and the next number representation, this system is called 1 complement representation. For this number system, positive value is the same. You can convert directly from binary to decimal and beginning with 0 0 0 0, side bit is 0. For negative, side bit is 1. To find out the negative side binary code, you just consider this one. For positive and negative, it's 1 complement together. Namely, for minus 2, for example, it's 1 1 0 1, right? It's 1 complement, then 0 0 1 0. Okay. Opposite together, invert bit by bit. Okay. So This number system actually it normally not used, okay, because it is have some disadvantage. For example, okay, this one, for 0 there are plus 0 and minus 0. That means you must check, okay, through binary code to compare that the value is 0 or not, right? Furthermore, maybe you cannot do addition directly. So in practical, in digital circuit or computer system, we use unsigned number and signed to complement to represent the number. Well, this is summarized, okay, for number representation. To complement, one complement, and sign magnitude. Okay. Now, if we want to do some binary multiplication, can we do it? At first, for decimal, it's easy, right? When you do multiplication, maybe you can do with this procedure. For example, 11 multiply 13. You do this one, right? 3 multiply 11, then it becomes 33. 1 multiply 11, that is 11, right? And then you add them together, okay? And this one actually is 110, right? But when you write, you just shift one position and do the addition, okay? This process is called shift and add multiplication. For binary number, also you can do this with the same process, right? 1 multiply this one, get this one. 0 multiply this one, get this one. 1 multiply this one, get this one. Okay, 1 multiply this one, get this one, and then you do the addition. Okay. Anyway, in the circuit, if you do with this process, you need the memory, right? To storage, to keep number with maybe 124, right? For memory. Okay. If you want to multiply, for example, 8 bit to 8 bit, that means you need to have 8, okay, 8 memory, okay, to store this number before do the addition. So it's not so good. So to reduce number of memory, maybe you may use this one. Namely, you just, okay, first of all, it is this example, you just prepare one memory, okay, and this memory, if you do multiplication between 4 bit to 4 bit, you prepare 8 bit memory, and at the beginning, the value in this memory is 0, okay, 0, 0, 0, 0, okay. After that, when you do multiplication, this one multiply this one, right? It should be this one, right? And then you do the addition, add this value, okay, add to this one, and update value. Then the memory will be update value to 0, 0, 0, okay. After that, when you multiply this to this one, you update the value to this one by do the addition. Shift one position first and add to this one. Add to this one and update its value by this result. After that, this bit multiply, then in because of 1, right? Then the same value 1, 0, 1, 1, and don't forget to shift more one position and do the addition and update the value into this memory, okay. And again, the last one, 1 multiply this one is 1, 0, 1, 1, and shift more one position and do the addition. After finish this one, then you obtain the final result or the product between this number and this number. So this memory, okay, observe that it will keep, right? Keep, okay, keep some part of their final result. Okay, it's called partial product. Okay, if you want to do the multiplication with a signed number in two columns, actually you can do the same method, same process, but just be careful about sign bit. For example, this one minus 5 multiply minus 3. If you do the addition, right, this one you must extend to 8 bit and do the addition. If for positive, extend by adding 0, right? If it's negative, you add 111. Okay, and especially you must be careful for the last one. When you multiply this last digit, okay, for all sign bit, right? Don't forget to negate this bit, okay, and then do addition. You obtain the final result. Okay, you can do the same like number multiplication. Just be careful about sign bit only. And for division, also you can do the same process like decimal number system. For example, for decimal number system, you want to divide 217 with 11. Okay, you just find out some number, okay, that multiply 11 and near to 21, right? So it's 1, right? And when you do subtraction, it's become 10, and then when you add 7 at here, then you just find out what the number, okay, that can multiply 1 and near to 107. Then it's 9, right? Then you get 9 and 99, and then do the subtraction, and the result is 8. When this number is less than this one, so you stop the process, right? And your result of division is 19, and remainder is 8. Okay, at the same process, okay, we can do this one also. For example, this one. Okay, find what the number, okay, maybe 1, right? Then you do 1011 and minus. Then your result is what? Is 0, right? 1 0. Okay, after that you add more digit by this value, right? And then consider what the value that multiply this one and near to this one. Okay, and repeat this process until finished. Okay, that's all.